Hi everyone, my name is Elron Bandel from IBM Research Israel, and in this talk I'm going to share with you how we build a collaborative platform to supercharge AI innovation. Before we dive in, let me give you a quick background on my experience in this field. It all started with my master's degree research on the robust testing of language models under challenging conditions. I also trained the first language model for Hebrew and was involved in developing the first Hebrew language model evaluation suite. Additionally, I co-authored the initial version of IBM's platform for language model evaluation, FMEval. Lastly, I led the development of Unitxt, a collaborative data preparation library designed to support community-based testing and training of AI models. Unitxt played a key role in IBM's large language models research and was the peak of my journey in the last 5 years focused on LLM training and evaluation. This talk is divided into 3 parts. First, I'll start with an introduction about the secrets of building super smart and innovative AI systems. In the second part, I'll tell you how we embraced collaboration and innovation with Unitxt. In the last part, I'll review Unitxt's global adoption stories and the future of AI innovation. This slide highlights the journey of developing Unitxt and how it encouraged collaboration and innovation. On the left, you can see a famous AI influencer, A.K. Khalid, announcing the Unitxt release. In the middle, you can see the figure showing Unitxt's best month yet, with almost 200,000 monthly users. And on the very right, you can see the IBM Research AI VP announcing Unitxt at the last IBM annual Think conference. Unitxt was developed with the help of many people, both at IBM and in the open source community. But first and foremost, I want to thank my managers and my team for their support and encouragement, pushing us all to climb this hill and do the best job possible. So, how we can build a super smart AI? An AI system that excels in many fields and continuously adapts to changes. The very basis of training AI models is by examples. A real problem is presented to the AI, followed by a solution written by an expert to this problem. By showing the AI many such examples from different problem fields with varied solutions written by experts, we can train AI with wide knowledge and skills. Testing of AI system is done in the same way. A real problem is presented to the AI, and the AI is asked to come up with a solution. Once we get the AI solution, we can compare it to the expert solution. Solutions with large similarity to the expert solution will give the AI higher scores. A wide testing area and topics can give us a good image of how smart the AI is. In order to train and test AI in so many different topics and knowledge fields, we need to bring expertise from many fields, such as math, physics, or history. We also want to represent different skills such as reasoning and knowledge across multiple languages like Hebrew or French. For this, we need experts from many fields. Furthermore, we need these experts to come up with new training and testing examples based on the areas the AI shows strengths and weaknesses. So, how can we get such a broad set of training and testing examples? There are generally 2 approaches. The centralized approach uses a governing entity, usually the AI owners, that directs and often produces the training and evaluation examples. On the contrary, the decentralized approach tries to streamline access for different experts to challenge the AI in their area of expertise. Periodically, the examples obtained from many experts are gathered together to form a broad set for training and evaluation. In this lecture, I'm going to support the decentralized approach and exemplify how it encourages collaboration and innovation. One example of decentralized collaboration for building AI with many experts is the work of a lab led by Shachar Don Ichia and Leshem Choshen, called model fusing. In model fusings, each expert trains its own AI model. Then, the mathematical representations of the neural network internals of all the models are interpolated together. The final model, received by merging many experts' models, is significantly stronger than the sum of its parts. But although model fusion shows promising results, leveraging decentralized collaboration, it is good only for creating models, but not for testing them. To create a firm and broad testing suite, we also need a protocol for decentralized collaboration by data sharing. Traditionally, decentralized collaboration through data can be done by sharing data frames between experts. Yet, different data frames are made differently and are hard to merge into one standard set. Another approach is to share the code repositories that the experts used to handle their data. But this approach creates a large amount of unverified code, which is hard to maintain. The approach we used in Unitxt to facilitate a protocol for decentralized data sharing and it worked best for us is data recipes. Data recipes provide each expert with predefined building blocks to construct their data pipeline. Sharing the final recipe is a concise way to pass the data, making its creation process simple and transparent. With data recipes, different experts not only can easily get the data ready for testing and training, but also draw inspiration from recipes created by other experts, fostering collaboration and innovation. The protocol of decentralized collaboration by data recipe sharing is simple. Each expert makes their own data recipe for training and testing the AI in their own area of expertise. Then, all the recipes can be crunched together to create one standardized set of examples for training and testing AI models with a wide expertise base. To support data recipes sharing, we created Unitxt.ai, a library for creating data recipes and platform to share them over an online community catalog. Unitxt, at its core, offers tools and a declarative language to build modular data pipelines for AI testing and training. When you build your data pipeline in Unitxt, it is guaranteed to be shareable. It's an easy way to get your expertise and unique innovations to contribute to AI frontier. Furthermore, Unitxt data recipes are cross-platform by nature and can be processed by all the major platforms for data loading and AI model testing, such as LME Valharnes, Hugging Face Dataset, and Stanford's Helm library. Now, let's dive into a real example to demonstrate what Unitxt data recipes really are. In this example, we have a multiple choice question answering task. The example is constructed from a question. what is the height of the Eiffel Tower? Two answer choices, A, 300 meters, B, 250 meters, and the answer from a French architecture expert, A, 300 meters. The root of the problem is that different data experts hold the data in different places with different forms and schemas. For example, on the left side, we have data stored on the IBM cloud in one schema. On the right side, we have data stored in GitHub repository with a different schema. Both have different fields, yet both are instances of multiple choice question answering task. When we want to combine them into one test set, we need to consolidate them into one standardized format for multiple choice question answering. For that purpose, each expert prepares the data recipe for standardizing the data to state that is ready for AI training and testing. The data recipe describes this process of preparing the example from a raw entry in the database to a production-ready testing or training example. First, we need to load the data from the IBM cloud. Then, we need to change the names of some fields. For example, the field query will be changed to question, the standard name for question in the question answering tasks. Next, we will add a textual template to the data containing instruction of what is exactly expected to be done by the language model. Lastly, all this text will be reorganized in the special layout and format this model was trained with. This short and concise data recipe is all you need to get the expert data ready for training and evaluation. On the right side, you can see the Unitxt declarative language for implementing this data pipeline. Unitxt data recipes consist of a sequence of operations over the data applied one after the other. This design choice is crucial for the data recipe's flexibility. At any point, you can add more operations affecting the final state of your data. For example, in the gray box, we introduce random textual noise to test or train the model for noise robustness. Also, we can replace any of those operations like the last operation, changing the metric we use to evaluate the model's prediction from a fuzzy match between the AI and the expert answer to a judgment of the AI response by another judge model. Each of the operators in the recipe are stored in an online community catalog, holding operators to fetch data from different sources, adjust data to different model required layouts, and instruction for different tasks presented to the model, provide general instruction for optimizing language model behavior, and set up performance evaluation metrics. Together, the Unitxt community catalog positions itself as the largest source for data manipulations suited for language model training and evaluation. Having all the data recipes from atomic operations stored and well documented in the Unitxt catalog is revolutionizing data processing for language models. Now all the data recipes can be easily shared and reproduced. They are fully transparent and clear and can be easily changed or adopted. Each of the operators is unit tested, which eases the maintainability of large amounts of recipes. If you are in the world of data preparation for language models, this combination is very important, and Unitxt suggests a really great combination of qualities that are essential for collaborative innovation. To sum things up, Unitxt helps different experts build data pipelines to get the data ready for testing and evaluating AI systems. All the recipes and the building block operations are stored in the community catalog, fostering collaboration and knowledge sharing. Periodically, all the data from the catalog can be gathered together to train and evaluate AI in many areas of expertise brought together by the Unitxt community. The use of Unitxt within an organization like IBM also has many benefits from the organizational perspective. First, by looking at the state of the organization's recipes catalog, the organization gains a clear map of important tasks for its domain experts. The organization can evaluate which models perform best on their specific tasks and where innovation is still needed. The organization can also train a custom internal model tailored to its unique needs. So, to summarize, Unitxt serves as a catalyst for collaboration, breaking down silos and fostering cross-team efforts, and encouraging innovation. The last part of this lecture is devoted to user stories and adoption across the globe. This part exemplifies how Unitxt is a catalyst for collaboration, accelerating innovation. Unitxt was launched here in Tel Aviv with one goal in mind: creating the best platform for accessing data for training and evaluating the next generation of AI system. Quickly after the launch, Unitxt was adopted by the WatsonX.ai teams at Almaden and Krakow for testing the performance of the WatsonX collection of language models. The contribution of this collaboration was celebrated in the yearly letter of IBM's Director of Research, Gil Dario. The WatsonX team contributed to the Unitxt catalog, among other things, many tools for question answering, evaluation, and training. Those tools for question answering were later adopted by a group of researchers in Bangalore, supporting their efforts in evaluating and training models with table processing capabilities. Building on the catalog tools for question answering, all they had to do to gain access to many table question answering datasets was to implement a single table processing operator. This exemplifies how collaboration helps experts innovate in the area of interest, focusing only on what they really care about. Fascinated by the new capabilities for testing table processing of language models, Stanford University's language evaluation platform has integrated Unitxt and started a collaboration on a new innovative testing benchmark for table understanding capabilities. Unitxt's abilities to test question answering of language model in different modalities and scenarios inspired two independent labs in Toronto and Dublin to explore using Unitxt for creating language models that evaluate other language models. Noticing they were both contributing to the same area of the Unitxt catalog, they started to collaborate and contribute new LLM evaluation capabilities to the entire Unitxt community. Building on the community work, the IBM MIT lab started different data recipes written by the community for testing models' behavior under different data augmentation. And this network of collaboration and innovation goes on and on and on and on. Unitxt broke silos, fostering collaboration and shared innovation between research labs that had never cooperated before. The Unitxt library was downloaded over 500,000 times. It is used around 100,000 times a month, supports over 1,000 different tools in the community catalog, and provide immediate access to over 50 million training and evaluation examples across different domains and areas of knowledge. To summarize this talk, collaboration is key to scaling AI development and innovation. Unitxt enables decentralized, modular, and shareable AI pipelines, breaking down silos across organizations and research labs, driving faster progress. The global adoption of Unitxt showcases the power of shared tools, data resources, and open source. If you want to learn more about Unitxt, watch our tutorials, and see amazing usage examples, please go to our website www.unitxt.ai. Thank you so much for listening, and please approach me if you have any more questions or you want to join our journey of developing the next generation of artificial intelligence.